You guys are probably going to kill me for this because, first of all, it's going to be a little bit long, and second of all, I'm going to show you why a whole bunch of things work, and then I'm going to just tell you something and not show you why it works. So, the first thing I want to talk about is we're going to talk about the derivatives of trig functions. And on the calculator, I'm going to show you a trick, and you're going to be like, what? I can't believe you can do that. But sorry, you can. You can find derivatives on the calculator. It's pretty easy, actually, if my calculator ever loads. And I'm not using my awesome software where I can edit the video and cut out all the parts where I'm like, because I don't have the license for it yet, and I'm working on that. First things first, if you want to find the derivative of a function, you can go to Math. Number 8 says numerical derivative. So let's find the derivative of x squared. So we could do d dx of x squared. And we want to do it at the point x equals 5. Now hopefully you all know what the answer is going to be. It should be 10, right? Because the derivative of x squared is 2x and 2 times 5 is 10. And the calculator shows us that. Yay, so cool. I wish you would have shown me that before. Yeah, well, you still have to do it by hand, so don't get too excited. But here's why I want to show you the derivative of trig functions. And there's the lunch bell. Awesome. Okay, so we're going to look at the derivative of sine first of all. I'm going to get rid of these guys. The derivative of sine. Take a look at the graph of the derivative of the sine function and see if you can tell yourself what that looks like. What does that look like? Hopefully you recognize that that's the cosine function because the derivative of sine is cosine. That's the first thing you want to write down. Derivative of sine is cosine. The next one we're going to look at is the derivative of cosine. Now when you say x equals x, that means you just want to graph it for all x. You don't want it to evaluate at x equals pi over 2. You want to graph it for all values of x. And hopefully you recognize this. Now I should be able to speed this up. How do I do that? I forget. I think it's in Window. So that took forever. I think if I go to Window and I'd say XRes, I make it like 10, I think that might make it go faster. We'll see. Okay, hopefully you recognize that that's the same as the sine function, except reflected over the x-axis. And as you recall, when you reflect a function over the x-axis, you make it negative. So the derivative of cosine is negative sine. Now take a look at this dude. Derivative of the tangent function. Now, before I show you this, I want to show you how we could figure this out all by ourselves. Because, and to be totally honest, this is what I do. I don't memorize. I memorize as little as possible. So I would do the derivative of tangent. Oh my goodness, I don't have a marker. Oh my goodness. I would say that tangent is sine over cosine. Oh, this is awful. Can I really not use my finger? No, I turned that off somewhere and I don't have a stylus. Pause. Okay, so I found a stylus. I would do the quotient rule, which says bottom times derivative of the top minus top times derivative of the bottom. Hold on. I screwed that up. Bottom times derivative of the top. Derivative of sine is cosine. And this notation is horrible. I should have x's after all of these. I just don't have a whole lot of time right now. Okay, bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. Notice when you do cosine times cosine, you get cosine squared. When you do sine times negative sine, you get plus sine squared all over cosine squared. Well, hopefully you recognize the one Pythagorean identity you have to memorize. Sine squared plus cosine squared is 1, and 1 over cosine squared is the same as secant squared. So the derivative of tangent is secant squared. Let's look at it. Derivative of tangent. Well, you probably don't know what secant squared looks like. So I should probably show you. Well, whatever. You get it. You can look at it, but that's what secant squared looks like. The bottom line is you need to memorize the derivatives of all the trig functions. Personally, I only memorize sine and cosine, and I derive all the rest. You guys tend to be more memorizers, so I'm guessing that you're going to want to memorize them, in which case I will write them down for you, and hopefully you will then memorize them. Actually, I should probably just Google them. It'd probably be easier for you to see. There they are. Memorize those 6 derivatives. That's it. You have to memorize them. That's all I can tell you. Okay, here's the other one that I told you were going to learn today that I wasn't going to show you why. I was just going to show you, but I changed my mind. I will show you why. Not really why, but more that it's true. The derivative of e to the x is e to the x. I know, it's crazy, but look at the graph. Here's e to the x. What? And here is math. 8 d dx of e to the x, not e to the ln. Clear. Math 8 d dx of e to the x for all values of x. You're going to notice those two graphs are completely identical because the derivative of e to the x is e to the x. Memorize that too. So you have 7 things to memorize before I see you next. Let's do a couple problems. Okay, get it? See it? Love it? Great. Flip my screen. I hope this isn't really messing with you terribly. Okay. Let's take some derivatives, shall we? First one we're going to do. You have a function times the sine of x. Now you could distribute, but then you'd have 3 sine of x's. You'd have a sine of x here, a sine of x here, a sine of x here, and that would be annoying. So we're going to do the product rule. The first times derivative of the second, derivative of sine is cosine, plus the second times derivative of the first. That's it, final answer. Can't do anything else. You could multiply this all out, but nothing would change. So that's it, that's all you do. First times derivative of the second plus second times derivative of the first. Better written as cosine squared x minus sine squared x. That is not an identity. The identity is cosine squared plus sine squared. So this is simply cosine squared x minus sine squared x. Final answer. Those were my notes. This one, the derivative of a difference is just the difference of the derivatives. So 2x minus, now we have a product, but it's, you can look at it as 3 things or 2 things. You could do 3 times x times sine x, but that would be silly because the derivative of 3 is 0. So we're going to look at this as the product of 3x and sine x. So we have to subtract this whole thing. first times derivative of the second plus second times derivative of the first. So, to simplify, 2x minus 3x cosine x plus 3 sine x. Final answer. That's it. That is all you can do. Isn't this fun? Okay, secant. Now, hopefully you memorized it. I'm going to show you how I figure it out because I don't have it memorized. Secant is 1 over cosine. Quotient rule says bottom times derivative of the top would be 0. Minus top times derivative of the bottom. But derivative of cosine is negative sine. And so I have minus negative sine all over cosine squared. So this is sine over cosine squared x, which can be broken into sine x over cosine x, also known as tangent, times 1 over cosine x, also known as secant. So the derivative of secant, d dx of secant x, is secant tangent x. And I just showed you why. So we're going to do 3 times, and then we're going to do the product rule of these two things. Does that work? Yes. Because if you think of it as this is one term and the 3 is another term, if you do the derivative, you do first times derivative of the second, which is what we're about to do, plus second times derivative of the first, which is 0, so that wouldn't even matter. So we can just put the 3 out in front and take the derivative of this part. So now I'm going to go first times derivative of the second, secant x times negative 5x to the 4th, that's the derivative of the inside, plus second, 7 minus x to the 5th, times derivative of the first, which is secant tangent. Secant x tangent x. That's it. That's your final answer. I think I meant to go forward. Oh no. Oh no. Oh no. I need one with e to the x in it. I thought I put one in here, and I didn't. That's not so good. Not so good. Hold on. Let me find one real quick. Derivative with an e to the x. E to the x tangent x. Perfect. Okay. Derivative of tangent. Again, I don't have it memorized. I know it's sine over cosine. Bottom times derivative of the top. Oh, I just did this, didn't I? Minus top times derivative of the bottom. So the top becomes 1. I remember that now, because this becomes sine squared, and cosine squared plus sine squared is 1. Over cosine squared x. So derivative of tangent is secant squared x. So first times derivative of the second, secant squared x, plus second times derivative of the first. That's it. Derivative of e to the x is e to the x. That's all you do.